AS1 Juno 9, question 7. A potential divider circuit is shown in figure 7.1. Rx is a fixed resistance of fixed resistor of resistance Rx, and Ry is a variable resistor of resistance Ry. The combined resistance of the two of them is 500 ohms, and the supply voltage is 25 volts. The output voltage is obtained between the terminals A and B. The maximum value of V0 is 15 volts when the sliding contact is at the position shown. Calculate the two resistances. And so it's really just a ratio of, we know we've 25 across our circuit, so if we've 25 here and 15 here, you must have 10 here. And so the resistance Rx to Ry, I'm just going to do it as ratios, is going to be 10 to 15. Because that's the ratio of the voltages. Now, we also know then that the total resistance is 500. And so what we're going to do then, maybe instead of just using these here, you could use these and calculate your total current in the circuit. But what I will do is I'll just stick it into the equation. So V out is going to be equal to V in R1 over R1 plus R2. And V out is equal to 15, in is 25. R1 we don't know, but we do know that R1 plus R2 is 500. And so when you rearrange all that, Ry, which is the R1, comes out to be 300 ohms. And therefore take that away from 500. So Ry is going to be equal to 500 minus 300, which is 200. So 300 and 200 are your two answers there. The position of the sliding contact is adjusted so that the output is 5 volts. A load of resistance 300 ohms is then connected to the terminals AB. Calculate the new value of V out. Right, so the output is 5 volts. From where A is at. So the first thing I'm going to do is calculate how much resistance that is equivalent to. Just check. And so you've got a value there of, we've got this is the Rx value, which is 200. No, Rx, I think I've written that the wrong way around in here, just to go back there. This one here was the R1 value. Yeah, so R1 is 300 and Rx is 200. They're the wrong way around. 200 and 300. Okay, so just back to this question again. The position of the sliding contact A is adjusted so that the output is 5 volts. Our resistance of load 300 ohms is then connected. Calculate the new value. So this is just the Rx resistor, and it has a value of 200, and this is now adjusted so that you have got something coming off here which gives you 5 volts, and we need to we need to calculate first of all what the resistance is here. So you've got 200 here and you don't know the split of these. But what you can do is, you know, the whole thing, the R1 plus R2 is still 500. And so we're going to use our V out is equal to V in R1 over R1 plus R2. And so we know our V out is 5 and our V in is 25. We don't know R1, but we do know in total you've got 200 plus 300, which is 500. So R1 is going to come out to be 5 by 500 over 25. Which is 100 ohms. Right, so if we go back to the circuit again then, really what we've got is 200 plus 200 here. So it's 200 for the Rx and 200 of the Ry. And then we've got our 100 here, and it's connected in, that's 100, connected in parallel with a 300. Okay, so you have to calculate the resistance of the parallel bit first. So the resistance of the parallel bit is 300 by 100 over 300 plus 100, which is 400. And that's going to be 30,000 over 400. And so that's 75 ohms. And then we want to calculate V out. So that's 75. This total resistance here is going to be 400. And so V out then, our new V out, is going to be equal to our V in, which again still 25. R1 is 75. And R1 plus R2 is going to be 400 plus. It's going to be 400.